Hi, everyone. My name is Mike. This is actually the first time I've spoken at a security conference. And I have to admit, I'm starting to get paranoid. Just 2 or 3 nights ago, I was sitting at home minding my own business, and I got an email through from Google. Someone is, your account has been recovered successfully. I thought, oh, what's going on? So I start digging in. Okay, 2-factor enabled. Yes, okay. And it's like, okay, so what just happened? Like, I don't know. But it can't be a coincidence the same week I'm going to speak at a security conference that my accounts start getting hacked. So now now I'm starting to worry about everything. And after this morning, I'm worried about quantum cryptography and the future of freedom. And so, okay. So my background is I've spent the last 5 or 6 years as a DevOps consultant, actually helping organizations implement DevOps, which is in a way helping them with software development life cycles. It's just a new way of saying the old thing. And usually it goes fine, except where it doesn't. And the places where it doesn't usually go well are places that security is an issue. The challenges are faced by banks, by people making, well, you know all the story, but these are very unique situations. So I've been spending a lot of time on this in recent couple of years and working with companies and starting to see some patterns evolve. So I thought I would try and gather together what I've seen and what works into, something that will hopefully help. Someone has hacked my pointer. See, I told you this paranoia thing goes deep. There we go. So, well, I do have a fancy agenda, but who wants to read something I wrote? Really, this talk is about, obviously, around DevOps, about how to automate your software development process in a way that makes sense for compliance, for people working in regulated industries, for people that are working towards standards, and security, where those 3 things meet. But don't worry, I do have a plan, so it's not all just made up on the spot. So we're going to begin with a little bit of bingo. Guys, there's some seats in the front here. Don't be shy. Does anyone know what this is? Just shout out if you know. It's Waterfall. It's a great way to make software. It's been in use for 50, 60 years. It works, I think, for the most part. I mean, I joke, but it has been relatively successful. It was the way we made software for a long time, and it seemed to get us somewhere in our state of evolution. So it wasn't that bad. This was the paper that introduced Waterfall to the world by Winston Royce. He was writing about how we should make software in the military. And actually in the paper he says, this implementation described above is risky and invites failure. But of course we only remember the diagram, so we implement the diagram. And this actually ended up becoming the Department of Defense standard for making software. But that's another story. What's this? Anyone seen this? Oh. You're all very lucky. Okay. This is Prince 2. Prince 2 is a project management framework, I suppose, that was kind of operationalized out of the British governments. It seems like the governments have always got some hand in a lot of this bad stuff. Of course, there's a lot of criticism against Prince because when projects fail that use Prince, they say it's because, well, you haven't used Prince correctly. But when it works, it's obviously because the process is perfect. Okay, what's this one? You're all maybe too young, I don't know. RUP, this is Rational Unified Process. This was an older way. It was very popular in the 90s to early, mid-2000s. Before Agile became really popular, this was a very common way to do larger software projects in organizations. Ivar Jakobsen was one of the pioneers about RUP and Rational Unified Process and actually UML and all kinds of stuff. He's quite an interesting guy, but in an interview he's saying, well, actually, branded processes like RUP or extreme programming are out because they're all just a collection of practices. Instead, practices will become first-class citizens. So, okay, maybe the frameworks are not that interesting. This one, I'm sure you've seen before. What's this? Scrum, yeah. And of course, Scrum is perfect too. This is Ron Jeffries. He says, I'm coming to think developers of all stripes should have no adherence to any agile method of any kind. And this is the guy that came up with that agile. So there we go. But again, I mean, all of these methodologies have been able to deliver some value, right? One last one. This is the V model. It's very popular if you're making medical devices or if you're making automotive software, this kind of stuff, where you've got, if you're trying to adhere to some kind of ISO standard, usually around software, nearly all of them have some kind of V model in them. And of course, they have their fair share of criticism as well, which we won't go into. One more? I picked the Japanese version of the diagram just to make it a little bit harder. This is my personal favorite. It's the one that I get up against all the time. It's ITIL. Has anyone ever worked in an organization that follows ITIL? Did you enjoy it? It's again, this is coming from the British government. So it's not just lately the British government's been a bit wacky. It's been for a long time. Plenty of criticism about ITIL, especially nowadays, where a lot of ITIL is about, putting in gates and processes and controls into the development process, which feels kind of antiquated these days. This one? DevOps. And of course, there's nothing wrong with DevOps. It's perfect. It's the magical unicorn that will solve all your problems, and that's why you're at this talk. No, of course, that's not true either. Like every process, I mean, really, following a diagram or not is not going to be the thing that decides whether you are successful. It's not going to decide whether your customers want your product. It's not going to decide whether you're secure. They're just frameworks for thinking. And in the end, it's always going to be people that are really what make the difference in the software development. So what can we learn from all of these different methodologies that we've had throughout history? Well, one thing is that they all have a diagram. This is very important. If you want to come up with your own methodology, you must create a diagram first. It's the only way it will stick. And we know this because with Scrum was the first agile method to have a diagram. Like Crystal, XP, all of those, they didn't really have a diagram that looked like the process. I think that is why Scrum succeeded. And I also think that's why SAFe is succeeding right now, because they've got this fancy diagram. They will all eventually be ridiculed, so whatever process you happen to pick today, you just have to accept that in 5 years you're going to be embarrassed by it. It's part of the process. It's just natural. Shouldn't worry about that. The most important thing is that they're all subject to confirmation bias. So nearly always, if you like a process, you'll see all successes with that process as being due to the process. And if a project fails with your favorite process, you will assume it's because somebody didn't do it right. It's kind of like security, right? A lot of confirmation bias. And speaking of SAFe, these frameworks encourage a lot of template thinking. They're often really, really attractive to organizations that would really rather avoid making decisions, right? Because you'd rather just someone else did the thinking and we can just apply the template. If we read the book and follow the process, take the training, get certified, then we'll know what to do. And then, we're finally going to fix what's wrong with us. And the reason is completely natural. We go through this over and over. Thomas Kuhn wrote this book in '68, which was about the way science changes over time. Has anyone read it? It's an awful book. Don't read it. It's really, truly terrible. It's very dense, academic, one sentence goes for a whole page kind of stuff. It's very, very difficult to read. But it had some very, very influential and good ideas in it, and that's why it's worth talking about. What he realized was he was doing a PhD in physics at university in America, and as part of his job at the university, he had to teach an undergraduate course for liberal arts majors around the history of science. And in doing so, he started to see a pattern over and over again in how science actually progresses, which was different from how people assumed it does or talked about it, even scientists, where it's quite common for scientists just to say we make a hypothesis, we test it, we take the conclusions and keep going around, and it's this kind of incremental improvement in our ideas. This is what science is. Maybe it is if you zoom out far enough, but actually if you look closely at science, the way it works is in a cycle, and generally you have a paradigm. And actually in this book is where the term paradigm shift comes from. So you have a paradigm, and the paradigm is basically the shared worldview that you and all your colleagues in your field have, whatever that happens to be. Where it could be, like some examples from the book are, he talks about going through from geocentric thinking to heliocentric thinking to Newtonian physics to Einsteinian physics to quantum theory. So they're all kind of paradigms of how things work in the cosmos, for instance. And what happens is that you live in a paradigm. Everybody in your field shares that paradigm. You have a shared basis. You have usually a shared education in this thing. But over time, anomalies start to creep in. Some things don't add up. More and more anomalies grow until scientists start to question the very foundation of their field. And then you get to a crisis where kind of all the ideas are getting flung around, and like people are looking for this new kind of underpinning that's going to get you through this crisis. And what takes you through that is this idea that you need a new theory which replaces the old theory, like the old theory that we're the center of the universe and everything is swishing by us, to, okay, maybe we're going around the sun and the sun is going around other things, and you need that new theory and you need data to back that new theory. And that will bring you around through the revolution into a paradigm change where you kind of throw out the old paradigm and you bring in the new one. And people that hang on to the old paradigm usually kind of get written out of their fields. They're not very interesting anymore. If you didn't get with Newtonian physics, in the 17th century, then you were probably not a thought leader in your field, for instance. And we can see this cycle in software too, going through all those different cycles, especially the one from, I would say, waterfall thinking to agile thinking. Alistair Cockburn, he was also one of the co-authors of the Agile Manifesto. He had this article, it was published in the Communications of the ACM back in '99. So before the Agile Manifesto came out. It's not online anymore because his website's down, but you can find it on the Wayback Machine. And he talks about people as nonlinear first-order components in software development, which is a weird way of putting it. But what he's saying is that he was really into methodology, into software development life cycles. And he would go to organizations and bring a methodology to try out on them. What he realized is that when he did that, most people in the team didn't care. They didn't care about his new fancy methodology. And the second thing he realized is they were able to ignore him and get on with their work anyway. And then that led him to think, okay, well, if I'm being humble about this, what do we learn? Well, the learning is that, projects succeed and fail. And you can succeed in any methodology. Any methodology can be made to work with the right people. And the best methodology in the world with the wrong people will never work. So what he saw is that the people are the most important aspect of your methodology in the end. And I think that that's really important. We often get stuck into especially in, when we start talking about DevOps and so on, we start getting to think about frameworks and what is this and what is that and tools and so on. But it's actually the people and how they behave and how they interact and how they do their work is going to be the biggest difference than any other methodology you can think of. Right, given that we will end up ridiculing whatever we pick and that most of them are rubbish, why would we want to do it in the first place? Well, Richard Branson seems to think we shouldn't. He says, you don't learn to walk by following the rules. You learn by doing and falling over. That's probably not bad advice if you're a businessman, if you want to try and create a new product or start a new service. You know, going out and, you know, failing is actually the way to do it. But it's not very good advice if you make software that can control economies, manages money, that can drive cars, that can control your insulin pump, or that manages the bridge that you cross every day. Now, there's a lot of software that you actually probably don't want to learn by failing. And that's kind of what this talk is about, you know, when you want to solve for that problem. And sometimes you just don't have any choice. Sometimes you need to define a methodology. Maybe you work in a regulated industry. Maybe you make financial software. Maybe you work in a bank. And you will have governing bodies or governments making rules for you. And these rules and regulations are things that you're obliged to follow, for instance, to keep your banking license. So what do? Inside your company, you look at those regulations and you translate them into your internal processes. And this kind of process of translation is usually very messy because the regulations have built up over the years, and so have your processes. And they've been done at different times by different people. So many of the processes you have in your organization, you don't know why anymore. You don't know whether they're to meet some regulatory need, or if they just happen to have been some manager 17 years ago really liked ITIL and thought that a change advisory board was necessary. So you have all this process that involve usually a lot of meetings and sign-offs and a lot of documentation, because at some point, the auditors are going to come in and have a look. And they're going to say, well, show me, how do you meet your regulations? You show them your process document. And say, great. Now prove to me that you do what you say in your process document. And that takes a lot of time, energy, usually a lot of effort to get to an audit. Is anyone working in a regulated industry right now? Okay, yeah. So other than regulated industries, there's a lot of organizations that want to or need to follow ISO standards. Like if you're making automotive software, then you're kind of obliged to follow ISO 26262. Many organizations just follow ISO standards because their customers demand it. It gives them access to a market that they couldn't have unless they had followed the standard. Some ISO standards are required, for instance, to work offshore in oil and gas. But the overall reasoning behind following an ISO standard is also to reduce costs, because the idea is that if you define a standard, you will reduce the number of errors in your process, at least process-related errors. And this is, Atul Gawande had a very nice book, which you don't actually have to read either, for the record, because all you need to know is that checklists actually work to reduce errors. And if you understand that, then you can figure out where in your world it makes sense to have checklists. Where are you forgetting steps in your process? But they do instill a higher kind of discipline. And this is the kind of discipline we'd like to bring to our software process if we're following, and if we're in a regulated industry and we want to follow some kind of standard. So we're, specifically in this world of compliance, the scope is across the whole value stream in a sense, from the customer need to it being delivered. So you can start from product management. Is it even legal to make this feature? This is a question you have to ask. Right? Are we allowed to make this feature? Does it comply with whatever data standards that we have to follow? Do we have to legally tell our customers about this change? Do we have to, if we're in a bank, do we have to tell the branch managers about this change? What has to happen in this product management sphere? will have to be part of your compliance process. And then over, maybe on the delivery side of the chain, when it comes to IT operations, you're thinking about what is our network security policies, how are we managing data recovery, disaster recovery, how are we doing backups, all of this stuff has to be taken care of. And then in the middle, you've got software development, which is usually where the Wild West of the process is, because, you know, this is where all of the changes in general being created in the system. And it's so much change that it's really hard for any end of the value stream to really have visibility into. So what organizations tend to do is to try and bring in a lot of process around this. To manage that risk, we need to have, for every release, we need to have this documentation, we need to have this information, we need the sign-offs from QA, we need, and this is a natural response to that volume of change coming, because we're basically asking how much risk are we accepting here unless we know what's going on. So the typical response is to bring a lot of paperwork to that problem. Now, Tim Ottinger says that when he's going around organizations, 90% of the software process is really a software prevention process. And I think that's right, because mostly the software process doesn't talk about how to make software. It's about how you control the quality of software. So it's all about putting gates and checks and standards into the process. Very little in the process is about how to produce great stuff and get it into the hands of the customers. And he says, well, if you really want to prevent delivery to the customer, we're going to add silos, batches, queues, approvals, and gates. So how do we get rid of all of that stuff while staying compliant, while staying secure, whilst having a control over our environment? And this is where I think that DevOps is starting to bring some answer to those questions, because a lot of the paperwork doesn't need to exist anymore. There's this famous parable about, I think it's Chinese, maybe it's African, I'm not sure. I think every parable is Chinese in the end. But it's, if you have different people looking at an elephant, and like you say, I'm looking at a spear, I'm looking at a wall, I'm looking at a fan, I'm looking at a rope, because they don't see the big picture. But the joke is with DevOps, it's exactly the opposite. No matter what you look at, you see DevOps. So it could be about culture and organization and bringing different silos together. It could be about deployment automation. It could be about all kinds of different practices. But everyone just kind of slaps the word DevOps on it and kind of, yeah, it's DevOps, so it's good. At least now. But remember, in 5 years' time, DevOps is going to be embarrassing and we'll think we should never have done it. But maybe there's something in this whole magical unicorn that can help us through the compliance maze. So the thing about DevOps is it is a socio-technical system. It's messy because it's about people. I mean, the whole word DevOps comes from bringing development and operations together to solve problems, which makes sense. And now, of course, it means more than that, because it means bringing security in and compliance and QA. And the whole idea is that you want everybody that's part of the value stream working together to deliver on that value stream. So we're trying to merge the silos organizationally, trying to bring the skills together to solve problems. But it's also technical. There's no getting around it. Where DevOps came from is a word to describe how development and operations work together to ensure that they can deliver high quality at fast rates securely. So this is a diagram from AWS, which I really like, because it's very different from what you normally see when, like, if you look back at all of those diagrams for process, they nearly all involve cycles. But this one from AWS is a bit different. I think it's a bit more honest, because what you have is a pipeline that ends up going to the customer, and they're going to swallow whatever you get. And then hopefully you're getting some feedback from that world. So it's definitely, it feels more like a bi-directional thing than a cycle to me. So I like this. There's a lot of research gone into DevOps as well, which is quite nice. It's the first time we've actually put some numbers on how process affects change in the world. So the folks at DORA, led by Nicole Forsgren, have been doing research for the last 7 or 8 years, asking thousands of IT professionals across the world questions about how they make software, how they deliver software, how they respond to failures, and so on. And now we've got some really good numbers about the differences between the best performing and the lowest performing. Of course, there's a big difference in organizations. We know this already. But what they see is that, that having a lot of practices around DevOps helps. Having the ability to respond to failure really quickly helps. If you have a deployment that fails, how quickly can you recover from that? That's actually a useful number to know. And with their research, they tie that to the financial performance of the organization. So what they find is that organizations that are good at DevOps are also usually much better than average in their financial performance. Not sure which direction, whether DevOps makes money or money makes DevOps, but at least there's a connection there. But I think that compliance and security is also a socio-technical system, whereas compliance has typically been, like if you work in a bank, compliance is a different department. It's actually designed to be like an external person coming into audit. So you might have, it's very commonly, at least in Norway, you talk about the 3 lines of defense. So you have, on the 3rd line of defense is Finanstilsynet, external auditors coming in, making sure the bank is doing what it's supposed to. And then the 2nd line of defense is internal audit, and they're going in, looking and making sure the teams are doing what they're supposed to. And then the 1st line of defense is like the people actually doing the work, and they're making sure that they're doing the right thing. But what I think is that we need to bridge some of this gap between DevOps and compliance to make it easier for DevOps to deliver. Because if you don't do something around how you manage security and compliance, and you're on the left side of the diagram, you're not able to go any faster than your compliance processes can manage. An example is the Change Advisory Board. Has anyone been in a Change Advisory Board meeting? Yeah, okay. This is where all the action happens. So for those of you that haven't, the Change Advisory Board is something I think actually also coming out of the ITIL standard where it began. But the idea is that if you want to put a change into production, this is part of the service transition part of ITIL. And then what we're going to do is we're going to all get in a room and discuss the change and make sure that the change is okay to go into production. We've done the correct testing, we've done the correct risk management. Makes sense, right? It makes sense if you're releasing once every 3 months or once every 6 months or once every year to go in and, you know, have we done all the testing? Have we done all this? If you want to release to the new version of your bank every 5 minutes or even just daily, you can't convene a meeting that's going to look into all of this every single day. It's just not possible. The thing is, the Change Advisory Board is living on right now in organizations, in banks that you bank with right now. They have Change Advisory Board meetings. And it's really risk theater because the volume of change that's going through those CAB meetings is so high that they've got no idea whether the risk is being managed or not. It doesn't stop failures from happening in production. It's just a bit of cargo cult that we have from our previous processes, which is a real shame. And there's also been research into this. So the DORA folks have been asking about change advisory boards. And what they say is that from the data that they get back in their surveys, external approvals, be it a change advisory board or IT change management team or whatever it is, they're negatively correlated with lead time. Makes sense. If you're going to have a meeting before you can do something, then it's going to delay how long it takes to get it out, and deployment frequency. Also restore time. It changes your time to recover from failures because you often have to create emergency channels for fixes and find other ways to do this change management process. by the data, it says it is in fact worse than having no change approval process at all. It will make you slower and make it harder to recover from failure, and it doesn't improve the quality. That's a good data point. There's the folks at IT Revolution, which also they're connected to the DORA team. They had a summit around DevOps and audit, how these things can go together. And I mean, they're highlighting the risk. The CAB exists for a good reason. The absence of change approval controls creates the risk of untested and unauthorized, I would say, or unauthorized code being introduced into production. And this is exactly what you don't want. Right? You definitely want to solve for this problem. The point is that the CAB doesn't solve for this problem either, because it's really hard to know whether untested code or unauthorized code is in a release. If you've got hundreds of commits in a release, it's really just not possible for somebody external to make that decision. So what do? This manual process becomes the blocker. Of course it does. Another interesting thing, if we go back to this translation process from regulations to how we implement the security in our organizations, is that our interpretation of the regulations is often not what's actually written in the regulations. I was doing an engagement for a bank in Australia, and everybody said to me, we had to do the CAB because of APRA guidelines. APRA is the Financial Sina for Australia. I said, we have to do the CAB for APRA. We have to have somebody from IT doing the deploy because we need segregation of duties. We have to do that. It's written in the standard. I thought, okay, well, where's the standard? Right. Yeah, I don't know. So I go and look it up online, I print it out, and then over a couple of nights I read it. It doesn't say any of that stuff. It really doesn't. It's just how they've interpreted it internally. And there's lots of organizations taking different approaches that are also managing to somehow keep their banking license. So we have to start to wonder, how do we know how much of this is from what we've interpreted and how much of this is actually necessary? Another challenge in this world is that if you have gone through a successful audit, you're likely to want to keep your process exactly the same as it's always been, because you know that doing it this way will get you through an audit. And that's the hard challenge that you have to try and break. But what they found is that DevOps can be a better audit compliance. This is actually how they've written it in the document, but you get the point. It is a typo, but this is how it's written. The DevOps is better practices. So, and it's not just written down in documents by people who are researchers. It's also what companies are doing right now. If you look at, this is ING talking about how they do compliance as code and how they have compliance dashboards and how they enforce compliance in their pipelines. Capital One is doing the same thing. There's many of the banks that are actually starting now. More of the new banks are doing it in this way. And what's interesting is that the reason they're doing it isn't because they're greenfield or because they're new. They're doing it because they don't have 20 or 30 years of legacy processes built up, legacy organization built up around how they make the software. Right, let's get to security. So say we say, okay, let's try and, how do we go faster while making sure that we don't have the risk of untested or unsecure code going into production? Well, one thing is that we could, as an industry, start spending more money on it. Like if you look at software security, this is research done by, who was it now? It was IDC and Gartner. So little goes into the software development part of the life cycle, lots into network and host security, lots into data and people security, but very little into the software parts of the system, which I think is it's a shame because there's a real risk there. At Google, they think that insider threat is one of the biggest things that their processes have to deal with. I'll talk about what they do later, but as one of their key security principles is to say, we not only need to be secure against ourselves, but against the outside world, but we have to be secure. And the fact that we don't know if somebody internal is trying to deploy untested or unverified code to production. How do we make sure our processes are built for that? And that also includes the idea that if like your credentials are stolen and someone steals your credentials, pretends to be you in Google, and tries to deploy something nefarious. So we want to have insider threat as a goal, managing that. We want to probably conform to some kind of process if we want to follow, well, if we're in a regulated industry, if we want to follow an ISO standard, we just want to be good. We probably want to define our process, write it down, so then it can be more or less a checklist to go through. Probably want to have 2 pairs of eyes on every piece of code reviews. This is also something we can check automatically as part of the development pipeline. Adherence to coding standards. This is very common in automotive, embedded, these kind of safety critical systems, but not so much in banks and so on. But at least this is something you can check. You want to check verifiable builds. You want to make sure that the build that you've created, you know you have a manifest for everything that's inside it, and you can cryptographically be secure that this binary is the one you built in your pipeline, and this is the one that you've deployed. Might want to check tests have executed correctly, and you've got the coverage you hope for. Some static analysis. Vulnerability scanning, this is becoming more and more common, and verifiable deployments. And this goes back to the verifiable builds. If you know what you build, then when you deploy it, you can check whether you built it or somebody else built it. And then, of course, you also need some traceability. You need to replace all of this meetings and sign-offs with automated processes, and you need to change this continuous documentation to be something that's produced automatically by your pipelines. So if you say we must have code reviews on every change that goes through our pipeline, you should record that you've done the code review somewhere in your pipeline. And you probably want to have immutable infrastructure. And this is really a lot easier to do these days with tools like Docker, because you can run your application in a container. It's nothing magical about that. But you can also, in that container, say that the file system is read-only. And that's huge, because once you have a read-only file system, a lot of attacks kind of disappear. A lot of attacks are involving getting a script onto your disk and then executing it to curl down something else, which is going to mine Bitcoin or whatever is the cool thing to do these days. So if you can make even your runtime environment immutable, have a read-only file system, have some controls on that, and also have an identification for everything in your system, like your software package, like your Docker images, like your VM images. If you can give them a cryptographic hash, so between those 2 things, you get full traceability to make sure that what's running in production is what you expect to be running in production. And Topal Pal from Capital One Bank says that if everything is source code, like if you're building all your environments and you're building your packages through automated means, then you also need no access to production. So if you're not writing anything to disk, if there's nothing happening on that production machine, then nobody needs access. And another thing you want to do is to try and standardize tooling. You don't want every team to decide their own tools, because you have a massive attack surface. If one team picks, I'll take an example. Even if one team picks AWS and one team picks Azure, securing both of those environments is huge. So that's just one way, but it comes down to the individual tools you're using as well, the frameworks. I mean, if you can try and limit the frameworks, and then you'd have far less projects to check for CVEs and so on. It's also faster to onboard new users and projects, and if everybody's using the same version of Ruby, for instance, or the same version of Ubuntu, it's really easy to upgrade it across the whole fleet. But if every different team is running a different flavor of a operating system or running a different flavor of the programming language, it's really hard to solve for security problems. So OWASP, they used to have a secure software development lifecycle project, I believe it was called. But recently they changed it to the software assurance maturity model. So it's more, I mean, it is security is baked into it, of course, because it's coming from OWASP, but they do have a working group that's looking around these kind of aspects on the software development chain. And when it comes to the build and deployment, I mean, what they're saying is basically use DevOps. At the top maturity level, build process helps prevent known defects from entering the production environment. That means you're driving that assurance inside your pipelines. And then the deployment process is fully automated and incorporates the automated verification of these critical milestones. They're using the word milestones, but in banks it's more typical to talk about controls. So, on the subject of implementing compliance controls, how would you even get started? And I think that the first place to start is to figure out where you are now. And this is actually a harder process than you would expect, because in order to do the value stream mapping from, say, the user need all the way through to a production change in a large enough organization, you will cross many, many different teams. You'll need to have someone who knows IT change management, someone who knows the network security, someone who knows the QA process, someone who knows the compliance officers, obviously the developers and the testers, and you end up with 20, 30 people to be able to actually do a proper value stream map. Once you know what your whole process is, then it's coming to decide what controls do you have now, and what controls do you want to have in the future, and figuring out where to automate your process and where to put the controls in. So that's the next step. What you want to do is to say, okay, from the need to it going into production, there is some kind of network of things that has to happen. You probably want to figure out where the controls are and automate that as much of that process as you can do. Now, when it comes to compliance, you also need to record that you've done these controls. So right now, you're typically running around all these different systems to figure out if you've got this compliance data that you need. But what you should just do is to put it in a system of record like Git. Git is a perfect place to store compliance data because it's immutable. It's an append-only journal. If you change data, you just get a new version of it. There's a lot of good reasons to use Git as your system of record. So as you go through your pipeline, do your controls, but also record it in some system of record like Git, because then you have a perfect audit trail. And then the next step is to actually enforce compliance in the pipelines. Make sure all your security controls have been done before something can be merged into your, say, your master branch, or before something can be promoted in your artifact management system. You probably want to have automated release controls as well, because at some stage you're going to send a collection of changes to production, and you need insight over that as well to manage the risk. And that's really it. That's the kind of the step-by-step process. What about the security culture? Just some learnings from different companies and different areas. One of the things that you should really aim for is just having one pipeline. It's kind of like standardized tooling. If you have a small subset of tooling, if you have only one pipeline, then it's a lot easier to add security controls, to add compliance controls in the pipeline. But if every team is creating their own pipelines, adding security controls becomes a big problem. So at ING, they started with nothing, and they ended up with 740 applications going through the same pipeline. Very, very different applications. You need to find a way to make it happen, but you can do it. This is Capital One. This is the controls that they put into their pipeline. Version control, static analysis, code coverage, vulnerability scan, open source scan, artifact version control, all of this stuff. Anything that goes into production must go through all of these controls. And when we I talked earlier about Google. They have this thing called binary authentication for Borg. Borg is it's basically their Kubernetes. This is where they schedule workloads in production in Google. And what they do is before anything, well, BAB is kind of like, it's a system that every deployment makes, that must go through before it makes it to production. And it works in 3 ways. You can have audit, you can have deploy time checks, and you can have continuous checks. So in an audit mode, you give BAB a policy, like the list of security controls you expect your software to have done. Then, as you go to deploy, you'll ask, BAB will ensure that you've got all of that evidence before you can go into production in Google servers. And this was going back to their insider threat problem. This is how they make sure that everything that goes to production has been authorized and has been code reviewed. So first off, you start by in audit mode, just getting the feedback, getting the alerts if you're not. And then the next thing is to actually have it as a control point where you don't get to production unless you have everything. And then the third level is to automatically go around checking production, monitoring the different versions of the different systems that are running, and making sure that they have all the compliance checks in real time. What they say is automating these checks have enabled the compliance team to increase both the scope of services covered in their compliance framework and their security frameworks, but also increase the adoption of appropriate controls. So more of their systems are under control, and they can add more controls to the system very easily. So this has been really important for them. So that's what I wanted to share. I hope it was useful. I just want to say that DevOps is a buzzword. We're going to end up thinking it's ridiculous. It's going to be like a magical unicorn in 5 years' time. It's going to be embarrassing that I even came to a conference to talk about it. Sorry, future me. But it does actually help when it comes to security and compliance, because it allows you to add a lot of security controls, build a lot of security controls into your pipelines automatically. So I hope you got something from this. Thanks. If you have any questions, just come up and talk to me.